Hey, welcome back, everyone. So you want to learn how to graph inequalities? Not a problem. Not only am I going to show you how to graph them, I'm going to show you how to graph them without creating a table, just going straight from the inequality to the graph itself. Okay? So let's pay attention. For right now, what I want you to focus on is just the numbers. We'll pay attention to the inequality itself in a minute. So let's go ahead and start here. When we have 3, we're going to start from the back, right? Because that's our intercept, our y-intercept. So we have a positive 3. What I'm going to do is go to the graph here, and I'm going to find, oops, let me get my pencil here. I'm going to find positive 3, and as you can see, I already previously put a mark here because I'm trying to make it quickly so you don't waste time watching me graph. So there's a 3, and from that point, I pay attention to my growth. My slope, that's my growth, at what pace I'm moving. So it's going to be moving up 2 and over 1, up 2 over 1, up 2 over 1, up 2 over 1. So as you can see, I already put some points in there, and that would be graphed already. Then I look at the symbol itself. Look at the symbol. It's a less than or equal to. Because of that bar underneath that makes it equal to, I have to make that a solid line. Okay, a solid line. So let's see here if I can grab a solid line here and graph it, hopefully. All right. There. Okay. And now we want to go ahead and graph the second one. So notice the second one starts at -6. So I'm going to go down and find my -6. As you can see right there, we have a -6. Next, look at the growth. It's a negative value. That means it's going to be going down, okay? Negative. So it has a growth of -1 because that's actually a -1 over 1. So from that point, I can move down 1 over 1, down 1 over 1, down 1 over 1, okay? So that's how it's going to go. So as you can see, I already put some points in there. So now let's go ahead and draw our line. But before I draw my line, look at the symbol. This symbol does not have an equal to sign. It's just a greater than sign. So this actually has to be a dotted line. And as you can see, I don't have a dotted line here. So I'm just going to sketch one here. Okay. A dashed line. Did I say dotted? My bad. I meant dashed. Okay. Yes, it's going to be a little crooked because of my technology here. But you get the picture of what I'm trying to do here. Okay. Wow, I trying to fix it. I even messed it up a little more, huh? All right, no big deal. All right, so hopefully you're doing the same thing as I'm doing it, right? Now, I have to, first of all, before I proceed, let me tell you what this means. When I have a solid line, it means that the values that my line crosses are included in part of the solution to my inequality. When I have a dashed line, that means that the values that I'm crossing are not included in the solution to my values. Okay? So make sure you make a note of that, write that down so you don't forget it. That's very important information. So now what I'm going to do is I'm going to graph the, grab the origin here, which is 0, 0, and I'm going to plug it in here, right? 0, and plug a 0 in here. So let's solve it. 2 times 0 is 0. So then I'm left with 3. So the question here then becomes, is 0 less than or equal to 3? Well, it's not equal to 3, but it is less than. Because that statement is true, then that means that right here on the side where my origin is, I'm going to shade all that area. So all this area gets shaded. Why? Because that means that all of these are values that make my inequality true. That's what that means. Let's do the second one. So again, we're going to plug the origin in, 0 and 0. And we end up with 0 is greater than negative, oh, excuse me, I was going to put negative x. What was I thinking? Okay. So there's my pencil. And -6. Oh, it was a -6. I should have just left the negative. All right. So 0 is greater than -6. Is the statement true? Is 0 greater than -6? The statement is actually true. Okay, and because it is true and my origin is down here, then all these values also become part of my solution to my second equation or inequality. What this means is here where you have the hash marks now that I've created here, that means that all of these values that are in here, but not including the ones crossing my dashed line, are a solution to my system. So I can plug any of these values and it would make my system of inequalities true. That's what it means. All right, so hopefully that makes sense to you, and that's as easy as it gets. If you like, I'm gonna put up another one and go ahead and pause the video, and so that you can try to solve it on your own, then hit play and see if you come up with the right solution. All right, so here we go. All right, so here we go. Here is our system of inequalities. Y is greater than x minus 3, and y is greater than or equal to negative x plus 6. Go ahead and pause the video and see if you can solve it on your own, and then hit play. So here we go. Let's graph the first one. Negative 3 is my starting point, so I'm going to start here. And, let me get my orange pencil here. Negative 3. That's not orange. Negative 3, right there. And then it grows at a rate of 1 over 1. So that means here it's going to go diagonally here. Okay. All right. So there, let's go ahead and put actually, you know what? This one does not have that equal sign there. So it's going to be a dashed line. And once again, I'll try to make it as correct as possible. Notice I keep curving down to the bottom. But you know what I'm trying to do. You see my point here. Okay? Oh, that went up a little. Don't worry about it. All right, here we go. Of course, if you're doing it on paper, yours should be a lot neater than mine, right? You got to understand, technology sometimes just doesn't want to cooperate. Here we have a positive 6 on this second one. So I'm going to find my positive 6. Go there. Put a dash. Actually, I should have used blue because it's my blue equation. And we want to be color coordinated, right? And then we got negative x, so negative 1. So it's going to go down. 1, 1, 1, 1, 1, 1, 1, 1. Okay? So now, let's go ahead and create a dash here. Okay? That's probably not 100% accurate, but you get the idea. So, now let's plug in the origin, right? So, for that, we'll just use some color that stands out. So this origin is what I'm going to plug in. So that means I'm going to plug in 0. So right here, I'm going to end up having 0 is greater than, and that x becomes 0, so it's negative 3. Is that statement true? Is 0 greater than negative 3? It is true. And because my origin is on this side, that means these values are the ones that make that statement true. So I'm going to go ahead and shade this area here. All right. Let's go ahead and plug the origin in again for this one here and here. 0 and 0. And let's see, what do we get? We get 0 is greater than or equal to 6. Is that statement true? Is 0 greater than or equal to 6? It is not. That statement there is false. So because it's false, I will not be shading this area in as part of this equation, but I will be shading this area. Let me show you something that I should have done. I assumed that the answer was going to be up here on this one when I shaded this one. So notice, because my origin was here, what I actually should have shaded was this entire thing, right? Because all these values make that one inequality true. That one inequality makes it true. But then when I go ahead and plug in my zeros up here for the second one, and I see my statement is false, then that means right there where that origin is, all these values right here make my second inequality false. So that means the ones on the opposite side make it true. So right here where I have my hash marks, that's the only section where all my values make my entire system true. Does that make sense? Because for blue, obviously all this would have been shaded too. All of this right here makes my blue equation, blue inequality true. All of these right here make my orange inequality true. but only my hash mark here make both of my inequalities, which means it makes my system true. All right? So hopefully I gave you a lot of hints there. Go back, listen to what I said, and write those down. That is going to help you make decisions later on when you're graphing your own on where your final answer will be. All right? And if you got some value out of this, please hit the subscribe and like button. And I'll see you next time on Math Quest. Have a good one.